So this is a pop quiz which was related to the Doppler effect and the pulse echo. Ultrasound can be used to check the cracks in a metal beams. A transducer emits a pulse of an ultrasound into a metal beam. The same transducer detects the returning pulses. A part of a metal beam is shown, and the beam contains three cracks, A, B, and C. So three cracks are there. A, B, and C are the three cracks. The diagram is the actual size. So when they say actual size, means you have to measure the length from this figure. The transducer detects the returning pulses from each crack. Explain why there is a returning pulse from crack B. So what actually happened? Like transducer is sending, when there's a radiation is there, it is reflected from A, some radiation reflected from B, and a very small proportion is reflected from C. So why? Because what is the reason? For example, if we send 100% radiation, so what will happen out of 100%, maybe say 30% is reflected back. So what happened to remaining 70%? That will pass through. And out of this 70%, maybe 30% is reflected back. So then remaining of 40% will pass through. So the question is why the transducer picked the reflection from B, crack B. So what is the reason for that? Some of the ultrasound passes through crack A, or when it travels from one medium to another, or different mediums or different density medium. So we call that as a refraction. So some of the pulse actually passes through or refracted through crack A. That is the first thing. And then it is reflected from the B, as you can see here, crack B. And why there's a reflection? Whenever reflection happened due to the difference in densities. Whenever two mediums have difference in density, if a wave changes speed, we call refraction. And usually reflection happen when there is a change in medium. So why there is a returning pulse from crack B? The points which you should mention. First thing, uh, the pulse passes through A, and it is reflected from B due to the difference in density. These are the points you have to mention. And same way, if the same question was there, why? If there was the same question, they say why there is a reflection from C. So we'll say the pulse passes refracted through A, refracted through B, and it is reflected from C due to the difference in the density. The next part, one pulse returned 1.4 exponent minus 5 second after being emitted from a transducer. Deduce whether the pulse has returned from crack A, crack B, crack C. You should take a measurement from a diagram. The speed of the ultrasound is given. So what we have to do, we have to use a formula, like we have the formula speed is here 2D over T. Why? Because it is reflected. So the time will be 2D divided by speed. And what we have to do, we have to measure for A, like we have to do calculation for A, calculation for B, and calculation for C. And we have to use a figure here. So because we have to measure a distance as they mentioned, the diagram is actual scale. So you have to measure this distance between and take an average, like try to take the same position. Like if you take a center, this one is for distance of A, this one will be a distance for B, and this one will be for distance of C. You have to use your scale or a ruler and measure these distances. And using those distance, find the time for each, and you can identify which from which one it is reflected. No, you have to identify which crack, so you have to do a measurement for each. For example, if matches with A, then you don't have to do for B and C. Yes, you can also do that. That is right. You can also do other way around. Like you have the formula speed is 2d over t. So if you work out the distance, speed multiplied by time divided by, you will get distance. And this distance compare with, but this distance you'll get in meter, convert it to centimeter, and then you will compare with the distances of A, B, and C. And you can identify that. That's other way to do the same question. Explain why ultrasound used to detect cracks in a metal beam usually have frequencies in megahertz rather than kilohertz. So what is the advantage? Look, when we have a megahertz means it will have a high frequency, so it will have a shorter wavelength. And shorter wavelength will give a more detailed image. How the shorter wavelength give a more detailed image? Because the reflection, so greater level of a detail possible as we have a shorter wavelength. So the pulse length of the pulse which we are using should, like if say this is say 10 centimeter. So when we use a length of a pulse, we should use a smaller, any length of a pulse, but less than 10 centimeter. So when we increase the frequency, as the speed is constant, so if the frequency is increased, the wavelength will decrease. And when the wavelength will decrease, what we'll get a more detailed image, like more detailed points of reflections. So the points here, you will mention the speed is constant in a medium. When a speed is constant, increase in frequency, reduce the wavelength. As a result, we'll have a detailed image. Detailed image means like you will have more points of reflection, because after a small proportion, yes, speed will change from each crack. Image here is refers to like more points of reflection will be there. Because what usually happen when the wave completed the pulse, the part of the wave is reflected. Like, for example, say I'm using a pulse of length 2 centimeter. So after 2 centimeters, some proportion of the pulse will reflect. After another 2 centimeters, some proportion will reflect. There will be a change in speed when it passes through the crack, but within the material, it will be constant, like within a metal beam. So after every 2 centimeter, there is a small proportion of a wave which will reflect. So we'll have a more detailed image. But if I use a longer pulse, like if I use a pulse of a longer length, then after this distance, like, so only 2 points where the reflection may happen before changing the medium. So advantage of using a shorter pulse is we'll have a more detailed points, more points where the reflection happens. So we say that we'll have a more detailed image. Is it clear?